Alright guys, we're going to keep going with this trigonometry unit. We're talking about special right triangles today, so that's on 116 and 117 of your notebook. So we're going to go ahead and go label those. If you're at home, you're going to need an envelope and some note cards, and then the handout that is attached to this video. So page 116, 13.3, special right triangles, and 116 as well. Okay, we're going to make some flashcards, and then we are going to work in a little book. Before we get started on the flashcards, talking about the answers in the book, I need to show you how to actually cut the foldable. So I'm going to grab one, and I'm going to show you how to cut it before we start working on it. So I'm going to go grab one. So this is a little different. I'm going to show you how to cut it, and we're going to actually do the examples, maybe the flashcards, all that stuff. Okay, so you got this. Zoom out so you can see the whole thing at once. Got this. It looks very strange. You're going to fold it. Okay, it doesn't matter on what side, because once we fold it, we're going to unfold it. But it needs to be folded into eighths. Okay. Like this. It doesn't matter what is actually on top of yours, but fold it into eighths. Okay. Then unfold it. Okay, you got it like this. It is unfolded now. Open it up and fold it in half again, hamburger style. Now, I have this right here. Here's the fold. Okay, this is the fold. I want you to take your scissors and right there where it's folded, not on the other side, where it's folded, cut on that line until you get to the other fold. So I've got to cut right through here. So when I open it, I've just got a hole in my paper. I need a hole in my paper. Once you have a hole in your paper, fold it in half again, hot dog style, and press it, holding it with both hands like this, press it in, and then tuck it over, and you will have a book. Special right triangles. Let me get this a little less bright so you can actually see the book. So it starts with special right triangles, and then these two, these two, these two, and you close it. This is where we'll glue it. I'll show you that again in case you need it. So it was like this, or like this. You took the ends, and you pushed it, and then you tucked that behind. So there's your book. We're going to get started now with the note cards and actually answering the ones inside of the book, okay? On the outside of your card, of your envelope, here's the flap. You're writing special right triangles. We actually talked about these on Monday. Remember when we found the 30, 60, 90 and the 45, 45, 90 trig ratios? That's what those were. Those were the special right triangles. So once you've got that, just put it to the side for a second. And we're going to actually draw the special right triangles. So this is your note card now. I'm doing the blank side just so the lines don't get in the way. And I'm not actually doing it to scale. I could, but I'm not. I'm going to label it. I know it's a right triangle. I did label that. 45 degrees, 45 degrees. Okay, the other day when we talked about these, the triangles were actually already labeled. Just so you know, if you ever get to a point where you forget or are confused about special right triangles, just know that the trig ratios we learned before work for these too. Okay, they work for these. It's just nice to know that a relationship exists. A special right triangle, these two side lengths are always the same, and I'm going to call them A. So they're the same. And the hypotenuse is always whatever the side length is times the square root of 2. Always. And this is a 45, 45, 90 triangle. That is one of the special triangles. We will keep this note card out. At the end of class, you're going to stick it in your envelope. Okay, so put that to the side. Let's draw the other one. On your other note card, draw another right triangle. They don't need to look like the sides are congruent because they're not. This is, again, it's not actually drawn to scale. I could draw it to scale, but I'm not. It's a right triangle. It is a 30, 60, 90 triangle. These are the only two that are special like this. Okay, so we've got a 30-degree angle here, 60-degree angle here. The relationship for these across from 30 degrees is always some value A. Across from 60 is always that value of A times the square root of 3. And across, or the hypotenuse, is always 2 times whatever that value is. So 2A. Your answers today are all going to be in perfect, like, radical form. Not perfect, but radical form. We are not going to round any decimals. So at the end of class today, you're going to stick these two note cards in your envelope. I'll tell you where the envelope goes in a little bit. We're going to go ahead and start Special Right Triangles, your book of Special Right Triangles. So as you have just seen, there is only two options, 30, 60, 90, or 45, 45, 90. The others, you just have to use the trig rules, ratios, whatever. So open that and let's do the first example. Alright, the first step for all of these is deciding which ratio I need to use. What type of triangle do I have here? I have 45, 45, 90. Okay, so I'm going to grab that card. What are the side length ratios in a 45, 45, 90? A. What's the other one? A times square root of 2. Or A on the square root of 2. You could hear it either way. Alright, I made these cards as note cards for a reason. I can pick them up and orient them the way I need to if I want to. I'm trying to solve for X. I'm literally going to match up my pieces in from this triangle. How am I going to solve for X, you think? What is the X the same as in this triangle? Okay, let's write that. X equals A. So I definitely am going to have to find A. How am I going to find A? 8 equals what? A times the square root of 2. So can I find what A is? Yes. If I square 8, that means it'll be A squared as well.
divide by the square root of 2. That's a good idea. You can do exactly what you said where you square it, but then you have to divide and then square root it. You can do that though. Okay, so that goes away here. You don't need your calculator because we're keeping it in radical form. A equals 8 divided by the square root of 2. Is this okay? No. What do I have to do when I have a square root on the bottom? Multiply by what? Square root of 2 over 2. Remember, that's rationalizing the denominator. What does that mean A is actually equal to? 8 squared, I want to put the number first, but either way is right. 8 square root of 2 over 2. We haven't done any that are like this yet. Does that simplify? 8 over 2? 4 square root of 2. That is what x is, as we just saw a second ago. 4 square root of 2. Again, if you see one of these on a test or something, and it's multiple choice, you can use your trig ratios instead. That works. And then you would just see which one was the closest approximation. Okay? Let's look at the next one. The next one, here's our triangle. 30, 60, 90, or 45, 45, 90? 30, 60, 90. What are the side lengths of a 30, 60, 90? A square root of 3, 2a. If you need to, write in a 30 right here. So I've made this card on purpose. I'm going to pick it up, use it for that. I have to find both x and y. Before I find both x and y, I always have to find a. What number is going to help me find a? 6 is equal to what? 2a. 2a equals 6. So a equals, these are better, it's so much easier when it's not that the square root coefficient is equal to some number, because these are going to come out as a whole number every time, or a radical form. Alright, a equals 3, so that means what does x equal? And what does y equal? We literally just plug them in. They're my two answers. Because x went with a, and y went with a square root of 3. Okay, turn the page in your little book. I want you to try these two. Special triangle is this example here. 30, 60, 90. If you get confused about how to set any of these up, I sometimes like to do this because it helps me. Sometimes I actually write right on the triangle, a equals this. X equals 2a. Y equals a square root of 3. Sometimes that helps if you're a little stuck on some of these. Which means I already know what a is. A is 1/2, so I don't have to worry about that. Now I just need to solve for either x or y, and I'm going to go in alphabetical order. X equals 2 times 1/2. What is 2 times 1/2? Next, I have y. Y equals a is 1/2. 1/2 times square root of 3. What is that? It is. Either leave it as 1. I actually don't want you to leave it as 1/2 square root of 3. This is actually square root of 3 over 2. I'll tell you why. You multiply. This is like over 1, and you multiply straight across. Is this okay, having a square root on top? Yeah, it's on bottom when we got a problem. Okay. Most of these you don't have to rationalize the denominator. We just had to on one of them. Sometimes you do, sometimes you don't. Alright, and I didn't write my side lengths up here. A square root of 3, 2a. Alright. If you use these, you have to memorize them. You don't get them given to you on the test at the end of the year. Alright, what's going on with this one? 45, 45, 90. What are the ratios then? A square root of 2. Again, if you're having some problems, take your note card, switch the orientation, and I like to write down what I have. This is equal to A. This is equal to A. This is equal to A square root of 2. So I don't have to solve for A. So what is X? What is Y? We got 2 word problems now. So turn the page. Again, if you have any problems with these, the trig ratios still work. It's just that these come out nice. Alright. The perimeter of a square, let's draw a square, is 48 meters. So draw a square, big enough to see it, but also small enough so we can still do work. The perimeter is 48 meters. What does that mean about each side? 12, because 48 divided by 4. I'm just going to label 1 for now. Find the length of the diagonal. What's the diagonal? Straight down the middle. Cuts it into 2 triangles. Do you know what type of triangles? 45, 45, 90. Which means we're going to use 45, 45, 90. Which means our side lengths are what? Where this is A, and this is A square root of 2. And that's what we're looking for. What is the length of the diagonal? 12 square root of 2 meters. It would be what? I think so, yeah, because it's 12 times 1.41. Yeah. You know what else you could use on this one, though? Is the Pythagorean Theorem. Yeah. So, you can use it for any of them. Do you see what there are so many different ways to solve these. You could use Pythagorean Theorem. You could use the trigonometric ratios. You can use these special rules. Let's talk about the next one. The altitude of an equilateral triangle. Try your best to draw an equilateral triangle. I don't think that is one. What is an altitude? From the base to the vertex perpendicularly. That is the altitude. I don't even know if perpendicularly is a word, but we're going to use it now. Perpendicularly. You like it? We're going to use it. Alright, here's 18 right there. It says find the length of a side. We want to know what this side is. Is this 30, 60, 90 or 45, 45, 90? How do you know it's 30, 60, 90? Yeah, in an equilateral triangle, all 3 angles are 60. Then this altitude cuts this one in half, so it's 30, 60, 90. So that's the card I need to pull out. Notice something. Aren't you used to seeing it this way? It's not that way now. It's like, flipped over. 60 goes with A square root of 3. I'm looking across. So 18 is equal to A square root of 3. That means we're probably going to have to rationalize the denominator. And X goes with what? 2A. I always know what it is based on this picture helps me because I can look at 60, I'm looking at across, 30 across, the right angle across. Okay, so we have to solve for A. 18 equals A square root of 3. Divide by the square root of 3, which is 18 over square root of 3 equals A. What do I need to do? Multiply by square root of 3 over square root of 3. So what is A? 18 square root of 3 over 3. Can I reduce that? 6 over 1, so it's just 6 square root of 3. Okay. What am I actually solving for, though? I mean, in the end. This piece right here, right? X is 2 times. And you said it would be what? You do not change that number in there. That's a good question, though. It's almost kind of like terms. You have 2 times 6. If you had 2 square root of 3, you would multiply the ones under the radical and the ones that are not under the radical. But if, like, you were just putting together the ones, like, if they're outside, they go together. So the answer is that length is 2 square root of 3. Just to fill this in, because it bothers me if something's not filled in, we're going to put A squared of 3, 2A. Alright, we are going to glue all of this in your notebook.
Okay, now that we have finished those, let's go ahead and glue them in where they go. You've got the envelope with your note cards inside. We're going to glue that to page 116. Okay, and then the book, we're going to glue that to 117. Alright, and we are done with that lesson. Alright, go ahead and start the assignment that's posted on Google Classroom.